Welcome. So in this video we'll learn about the Rennet action on casein, which is a major reaction during the cheese making process. Now before starting the topic, that is how does Rennet act on casein, that's basically it acts on kappa casein. So we first see the definition of caseins and whey proteins. So as we can see on the slide, that casein, how will you define casein and how will you define whey proteins, that we have to know. So caseins are a group of phosphoproteins. How will you define caseins? That caseins are the group of phosphoproteins which precipitate on acidification of milk at pH 4.6 using sodium acetate and acetic acid. So how will you define casein? That caseins are the group of phosphoproteins which precipitate on acidification of milk at pH 4.6 using sodium acetate and acetic acid. Now they contribute around 80% of the total milk protein and 2.6% of the milk protein. So they contribute to 80% of the total milk protein, or 2.6% of the milk they constitute. And denaturing agents and heating seems to have no effect on the secondary structure of these proteins. So the caseins are considered to be as already denatured proteins because they lack a secondary or the tertiary structure. They are having very little secondary or tertiary structure. So that is why the denaturing agents and heating have no effect on the secondary structure of the proteins. And they exist in micellar form with a size of around 10 to 300 nanometer. So they are occurring in micellar form with a size of 300 to 10 to 300 nanometer. Now the distance between two casein micellar is around 360 nanometer. So if you see that around this is a micelle, and then this is another micelle. So the distance between these two is around how much? Is 360 nanometer. Now coming to whey proteins, how do you define whey proteins? Whey proteins are defined as a group of proteins which remain soluble after removing 80% of the casein on acidification of milk at pH 4.6 using sodium acetate and acetic acid. So as we know that if we are adjusting the pH of milk to 4.6 using sodium acetate and acetic acid, the casein gets precipitated, and the group of proteins which remain soluble after removing these 80% of the casein on acidification of milk at pH 4.6 are termed as whey proteins. Now whey proteins are considered as soluble proteins and present in two solution and contribute 0.6% of the milk. They contribute how much? 0.6% of the milk they constitute. Now if we see the casein is to whey protein ratio in different species. So in cow milk, casein is to whey protein ratio is around 80 to 20. In human milk it is 40 to 60, and in mare milk it is 50-50. So they are present. So in cow milk majority is the casein protein, in human milk majority is the whey protein which is there, and then in mare milk they are in equal concentration of 50 to 50. Now coming to the topic of today, that is Rennet action on kappa casein. If you say kappa casein is a molecule having 169 amino acids. So here you can see that the total 169 amino acid is there, and then N terminal is glutamic acid and the C terminal is valine. This is here it is called N terminal, and here it is called as the C terminal. And the 1056 position, that is very important position, that if you know this 105 amino acid is phenylalanine and 106 amino acid is methionine. So Rennet act on this position 105 106, that is phenylalanine and methionine position that Rennet act in. So casein micellar are stabilized by kappa. That means that is if you see the structure of casein micellar, this is the casein micellar is spherical in shape, and at the core we know that we are having alpha S1, alpha S2, and beta casein, and at the kappa casein protrude the casein micellar as a hair structure. So this is kappa casein. If you see, this is the kappa casein, and because of this kappa casein, the negative charge on the kappa casein and the steric stabilization, steric hindrance, the casein micellar are stable, and they are not getting precipitated, they are not getting aggregated because of the kappa casein. Now you can see that kappa casein micellar are stabilized by kappa casein, which represents 12 to 15% of the total casein. They represent how much? 12 to 15% of the total casein, and is located mainly on the surface of the micellar. That is its hydrophobic and terminal region reacts hydrophobically with calcium alpha S1, S2, and beta casein, while its hydrophobic C terminal region protrudes into the surrounding aqueous environment, stabilizing the micellar by negative charge surface and also by steric stabilization. So this is the meaning. So if you see, just to give you an idea, that casein micellar is spherical in shape, and then kappa casein protrude as here from the casein micellar, and alpha S1, beta, alpha S2, beta casein are at the core of the casein micellar. Now very important reaction that casein Rennet always act on the position, as told you, 105 106, the phenylalanine and methionine bond, and producing the para kappa casein. The fragment 101 to 105 is termed as para kappa casein, and glycomaproproptide, the reason is 106 that is part of the kappa casein, so it is para kappa casein. So glycomacropeptide, which is forming the fragment 106 to 169. So glyco means that since they must contain most of the sugar present attached to the kappa casein, so it is known as glycomacropeptides. Now in this bond is many more sensitive to rennet action than any other bond in the casein, so this is the most sensitive to the rennet action. So when rennet action casein, you will have the para kappa casein and glycomacropeptide, and this para kappa casein in the presence of calcium at a temperature above 20 degrees Celsius get precipitated to form gel, that is cheese making process. During the cheese making motion we have the gel formation. Now what is happening is that when 80% of the kappa casein is hydrolyzed, so we know that we have a casein miscellany, and then here are producing around 8, and then if this 85% of the kappa casein is hydrolyzed, that is these are hydrolyzed, 85% of the kappa casein is getting hydrolyzed, then the colloidal stability of the miscellany reduced to such an extent that they coagulate at a temperature above 20 degrees Celsius. So temperature is during cheese making we are making use at optimum temperature 30 degrees Celsius we are making the cheese making. And in the presence of calcium ion, because your casein which are sensitive to calcium are also get exposed, so in the presence of calcium this aggregation occur, and this is known as the secondary phase of rennet action. So primary phase is that action of rennet on the kappa casein and producing para casein and glycomacropeptide, and secondary phase is that in the presence of calcium at a temperature above 20 degrees Celsius the coagulation is happening. Now if the temperature is a little higher, say 50 to above 55 degrees Celsius, then it can also denature the rennet. And if it is still higher at temperature greater than 70 degrees Celsius, what happens is that there occur beta lactoglobulin kappa casein complex, and which again prevent the action of rennet on the kappa casein. So the optimum temperature is around 30 degrees Celsius, and then the coagulation not take place at below 20 degrees Celsius, because temperature coefficient of the secondary reaction is very high. Now GMP, as I already told you, that since they contain most of the superfluous, there is no glycomacropeptide and are hydrophilic and diffuse in the aqueous phase, so they go into the way, whereas your para kappa casein stays with the casein miscellany. It contributes around how much, 30% of the kappa casein or 40% of the total casein. It constitutes 30% of the kappa casein and 40% of the total casein. Now removal of the micropeptide from the surface of the casein miscellany reduces their zeta potential. Now if you remove the kappa casein, that 85% of the kappa casein has been removed, then it obviously will reduce the zeta potential, and that is reduced from minus 20 millivolt to minus 10 millivolt, and also the stirring hindrance is also reducing. And because of these factors, the aggregation of the casein miscellany occur in the presence of calcium. Then the proteolysis of kappa casein is this first phase is known as the primary phase or the secondary phase, and the secondary phase is the aggregation of the coagulation is happening in the presence of calcium at above 20 degrees Celsius. That is happening during the secondary phase of coagulation. The para kappa casein is hydrophobic and remains attached to the miscellany core, and it is approximately 2/3 of the kappa casein miscellany. So kappa casein molecule, it is forming how much, 2/3 of the kappa casein, and it remains with the cheese. So it because it contains hydrophobic amino acids, so it will remain with the cheese, whereas GMP, which is more hydrophilic, which contain the carbohydrate portion, and also the polar amino acid will go into the whey. So this is this evergreen reaction, and this is a very important reaction during the cheese making. Thank you.